Good afternoon, everyone. Welcome to the SpringOne session, where we're going to go and talk about Spring data and distributed data stores. So before we get too started, it's always obligatory to have a description about who the speakers are. I'll be very quick through this. My partner in crime here, though, has a long list of items. So it's David Turanski and myself. David is, just to give him some introduction, he is the lead committer for the Spring Data GemFire project, and really truth, he's the one that makes a lot of this stuff possible. My role is I'm a SE with VMware. I like to play around with distributed systems, have for an awful lot of years. And when I'm not working, I'm also president of the New England Java Users Group, one of the largest and oldest in the world. Anybody here from New England? All right, make it to an eJug meeting? Good. All right, so we'll go straight into the meat because, well, introductions are not that interesting. All right, so we've got a problem here. When I first started out, databases were measured in the Ks, and we thought that was impressive. And then it grew to the megabytes and the gigabytes. Had to learn a whole new vocabulary. I didn't even know what gigabyte was. And then terabyte, which is where a lot of our databases are these days. And now I'm starting to hear people talk about petabytes. Does that describe the situation that you're in? Non-stop growth. And that's causing us a huge problem. We're encountering bottlenecks at our network I/O, at our disk packs. It's just not working. Queries that work just fine in the lab at 5 milliseconds, 10 milliseconds, whatever it is. When we get it out into production, we get these little performance spikes. It's no longer measured in the milliseconds, it's now measured in the seconds. And then it goes away quickly. Does this sound familiar to all of you guys? And what happens? Well, we have a fire drill. We go bring in 10, 20 developers, system administrators, and we try and figure out what happened in those 5 to 10 milliseconds when those queries jumped up there. And because somebody was complaining, we have to do something about it, even though right now it's working just great. The bottleneck is cleared, traffic's moving, everything's nice. Why are we encountering these problems? One of the core problems is explained by the laws of physics. And there's not much we can do. Going for fancier hardware is not really going to solve these problems. If we think about data movement, if we're going from the K to the petabytes, we're talking about moving ever larger amounts of data. If we're just moving a megabyte in memory, then what we're talking about is 250,000 nanoseconds. But if we're talking about reading a meg of data from disk, we're talking about first doing a seek, 10 million nanoseconds, so we're at a whole new scale of numbers, plus another 20 million for the actual read operation. So we're now introducing blockages because it's taking longer to do our queries. Things have to wait for those roads to clear and the data to pass through. Worry not, though. There are lots of solutions out there to these problems. There's React, there's Hypertable, Mongo, Neo4j, GemFire, SQLfire. All of these as possible solutions to the performance issues that we're encountering with our Oracles, our DB2s, our MySQLs, and other relational databases. For all of you, is the list of which database to choose here clear to you? How do we choose? How do we choose without going down the wrong road? How do we choose without causing a situation that will lead to us looking for another job? because, well, the technology didn't really work as well as planned. So as I mentioned, I head up the New England Java Users Group. I'm always hearing people saying, we're going to dump all of our databases for this new database. You pick the name. And I go and say, huh? Why are you going to dump all of your databases? What sort of logic are you going to use to choose? Do you understand the dynamics for these new databases? I get blank stares quite often. How do you choose? Well, I think one of the first things that we have to do is we have to understand what's new about these databases. Well, probably one of the most substantial differences now is we're going from vertically scaled databases to horizontal. What do I mean by that? We have our application. It's a nice little database. It works for the number of users we have. It is such a nice database. We now have a lot more users. And we still have that same skinny pipe that's moving the data at 1 meg every 10 million nanoseconds for the LAN movement. Does it sound familiar? I don't generally find this solution works. And so what happens is our local database salesperson comes in and they say, buy our bigger database and with our bigger pipe, and that will support your volume of users. Does this sound familiar? What this is vertical scaling. We still have a shared architecture. I like to compare the traditional database architecture to the Boston highways. Anybody go driving through downtown Boston? All of the roads converge into one small place. If we're talking about a lot of data, that just doesn't work. It doesn't work at all. We need a new model, and that's what all those solutions I was talking about are trying to address. What we need is the ability to federate the problem into a bunch of smaller commodity boxes. On these commodity boxes, we can now stitch together more CPUs, more memory. And most important of all, we've got more pipes to move that data through. So instead of having one pipe moving 1 meg of data at 10 million nanoseconds, in this diagram here we have now 5 pipes moving 1 meg at 10 million nanoseconds. We can't play around with the laws of physics. So maybe we should try and play around with how we organize our databases. By doing this, we can achieve horizontal scalability, or rather near horizontal scalability. True horizontal scalability, like true complete vertical scalability, is right there with the perpetual motion machine. So let's go and look into this horizontal scaling bit in a little bit more detail. So I'm leading with the benefit of scalability for our distributed database as my alternative to the central store. So I have a situation here. I've got 4 sets of clients, however that is, and I have a horizontal server set that's just 3 nodes. I don't have more nodes there because the screen is limited in size. You'd probably, for your real-life example, have many more nodes. The thing to note here is this graph for each of the servers. This is the request response time average for each of those servers. What we see is that by having this set of common pipes shared, stitched together, we're achieving a fairly consistent, or let me change the use of the words because we'll talk about consistency, predictable response time between the server nodes. It's pretty tight and it's predictable. Now, I double my number of clients. I want that predictability to remain. If I've set up a distributed data architecture, I will achieve that predictability. Because what I'm doing by scaling out is I'm breaking the problem up into a bunch of smaller components. And so as I'm adding those additional 2 servers, what I'm achieving is I'm just horizontally scaling. Now there's always going to be some administrative functionality, and that's why I say that it's nearly horizontally scalable. But we can keep on doing this for quite a while. We can extend this screen way out there into a couple rooms before we'd hit any sort of limitations with most of the distributed data stores out there. So, scalability we solve with horizontal and federated systems like GemFire, SQLFire, and some of the others. Durability is a problem that I hear people raise commonly when they're considering moving to an in-memory store. We know what happens when you have an in-memory data store. You turn off the switch, the big red switch, everything gone. So, you're going to go put your corporate assets out on an in-memory store that is that volatile. Does it make anybody in this room a little nervous? A little? Yeah. Well, I would argue that in today's federated stores, that actually you have a better level of durability than what we ever had with the old platter centralized systems. Have any of you experienced a hard disk failure on a database in your career? Yeah. My most notable was on a 1.5 terabyte instance, and it took a day and a half, 2 days to completely recover. That's not durability. That's not high availability. We need a better solution here. So let's talk about the additional durability that we get when we consider it from a GemFire, SQLFire perspective. And the other federated stores have similar solutions. So realize you'll be able to apply these sorts of ideas there probably as well. So if we're talking to our chief architect, our CIO, they're comfortable with relational databases. And frankly, they should be, because the relational database has been a reasonably successful paradigm for the last 20 years. What we can do in GemFire is we can set up a synchronous or an asynchronous communication channel so that any writes or updates made to my cluster here gets automatically propagated to my legacy relational database. Okay, what did we just accomplish? What did we accomplish with this? Well, yeah.
You separated reads from writes.
I've separated reads from writes, and also I can block the transmission of those records such that I can make more efficient use of the database. So if I have a database that everybody's really happy with, that they've spent millions of dollars and they're happy continuing to spend millions of dollars in support for, we don't want to take away that pleasure of spending all that money. What we want is the ability for that Crystal report writer to continue to run as it has been untouched for the past 20 years. But we can block the transaction so that we have an eventual consistency between my primary repository, being my federated store, and where my reporting store is. Now, when I'm talking about eventual consistency, what I mean is at the very moment that write is posted, it's not going to be visible here. But in whatever blocking time I've set up, plus network transfer time, it will become consistent. I'm a firm believer in ACID. No, not the drug thing. I never got into that. But you have to have atomic, consistent, isolated, and durable. That hasn't changed with these new databases. And don't let anyone tell you that it has. So we have to pay attention to consistency because your CIO and your CFO will have a conniption if you ignore that. We will achieve that with that transfer. But there's more. I can also go and communicate with my web services. Do my writes, read refreshes to my web service. Okay, I have this, big deal. I was talking about shared nothing architecture a little while ago when I was commenting about the problems with the current centralized. And what I mean by shared nothing is I do not want to have one single point of failure. I do not want to have a lot of data moving back and forth. Remember, each meg costs on average 10 million nanoseconds. I don't want to move data unnecessarily. With the GemFire engine, what I get is the ability to have a data store on each of the server node components. Now, this is an excellent thing for two reasons. One, it's local. I don't have to move it across the network. So any sort of restore, getting to the second reason, is done as a local file read. I don't have to have a whole bunch of SanDisk storage. I don't have to put in fancy network to support the disk drives. I just take whatever disk came on my DL380 or whatever it is, since we're dealing with commodity hardware. Now, continuing on that second benefit, getting back to that failure of the 1.5 terabyte data instance, part of the problem of that was loading up all of those tapes. You know, those old 6250 tapes, you know, reel-to-reel things. It takes a long time to move that data. Now, if I'm dealing with a centralized data repository, can I just load a portion of the database? Probably not. But with this approach, server 1P dies. It fails. All I have to do to recover it is restart it and reload my local data repository. So if I've got 10 nodes, then I'm only loading 1/10 of the database. That means my recovery time is much faster. That's a real strong plus. But I'm still dealing with the 20 million nanoseconds on a read for data. So I'm kind of getting there, but I'm still missing it. And that gets us to our fourth option. And our fourth option is to have redundant copies. With GemFire, I can have up to 4 copies of the database. So now if I lose that server 1P, what will happen with GemFire is, assuming that this is where all the backup data for it, this is now going to become my primary data repository. And so we're no longer talking about just high availability and consistency. Do you realize we're now also talking about achieving continuous availability? Because I'm never going to lose access to the data, so long as I don't lose a second node with this sort of topology. If I'm worried about losing a second node, then I want to have 3 copies. If I'm worried about losing a fourth before my full restoration of the network, then I want to have all 4 copies. With some products like GemFire, we can even take this one step further, and we can get into geographic distribution. So we can put 2 data centers on the edge of a power grid, and if we lose power, as happens in my neighborhood all the time, that's okay. I don't have to make certain that I have, you know, Saudi Arabia full of diesel fuel for the generator. I switch over to my other data center. Nobody's the wiser. The problem's been lost. Now, with tools like GemFire, I can choose any one of these 4 options. I can choose it based on my non-functional requirements, not based on what somebody sold to me. And that's important. We have to think about what are the requirements that we're trying to serve. And we need to think about the cost, of course. We also need to think about network impact, true durability in terms of a real catastrophe, availability in terms of continuous or not. This is what is addressing that blockage talked about earlier. But we're also dealing with huge amounts of data. So we have to think about the speed of query. If we're bouncing between all of these servers, we can end up with a lot of chatter. And so with tools like the GemFire engine and others, what we can do is we can have a data-aware query that will know that this query should only go to that first node. Now, There's a lot more to the federated data stores. That's for another session. I wanted to introduce the ideas. It's pretty cool. It's pretty neat. But I've got applications already. I have to make the transition from my current applications to this new world. Well, what do I have to do if I'm going GemFire, if I'm going with a key value repository? Well, here's an example. I want to go and create my friend Dave Turanski in my database here. I go person equals new person. Cool, nothing, no rocket science. Region put, well, region is the term for a table. And I'm going to get the ID. Hey, this is just basically hash maps. And then I go and get that row. It's not hard. It's very easy. Now, think about doing it to your current application. Think about all of the domain layers that you're going to have to go and change. Well, I will say this is one of the reasons why SQLfire was invented, which is a SQL interface on top of the GemFire engine. But we're not going to talk about that sort of technology. We're going to focus in on some of these alternate technologies because we have a problem here. They are different and they need to be different. They have different ways to save. They have different ways to read. They have different queries. Here we've got an OQL query from GemFire. Looks kind of SQL 92-ish, but what the heck is that slash there? That's for another session. Traditional ORMs do not support these features. We have a problem. We cannot just use the benefits of Hibernate as we've been doing for so long. They do not support these features because it is hard to create a one-size-fits-all solution. How do we do a select for a document store or a key value or a traditional SQL columnar? How do we do that? It's hard. Spring Data was created as a technology to bridge some of these gaps. And I will be honest that when it first came out, I was very skeptical. I was expecting the folks to call me out on that, but they didn't show up to this session. But so what does Spring Data do? Well, it provides a very familiar Spring. Hey, it works. Very consistent programming interface. But most important of all, it does that without going and hobbling all of these great new solutions to some generic homogenized type solution. We want these tools to have the diversity. We want these tools to have the strength that their creators intended. And Spring Data, I would argue, with the 1.2 release, achieves that. And it achieves that with a wide range of database technologies. GemFire is supported, being the new one I've been talking about, but you can also use it for your Oracle database, your DB2, Mongo, Hadoop, Redis. The list is going on. So I said this is a hard problem to solve. How do we solve it? Well, the secret sauce that the team came up with is something called repositories, or at least I consider this to be the secret sauce in Spring Data. Let's look at it, and let's look at it from the context of a standard application. So we've got our UI, our controller, our domain objects, and our data access going to our traditional SQL database, which we want to get rid of, and replace it with something like GemFire or Mongo or Neo4j or whatever. What that means is we have to get rid of the data access tier. We've all done this before in our careers, especially those who have played around with web services. And the way we've solved this is we've set up separate proprietary interface layers going to our GemFires, our Neo4js, our MongoDBs, and my favorite database, the other database. Begins with O. We need something that's more consistent. And I don't mean consistent in terms of data moving. I mean One mindset, because when I'm chasing after a bug at 10, 11 o'clock at night, I don't want to think, let's see, GemFire works this way, Neo4j works that way, Mongo, oh God, I don't want to deal with that. Spring Data Repository gives us a common interface to communicate with all of these technologies. Sounds great, right? You guys interested in that? Well, seems kind of unrealistic. What goes on here? Now, before I go too much further, how many of you have been to another Spring Data presentation at this conference? Okay. So I'm not going to go and belabor too much in terms of the repository architecture. Suffice it to say that we've got our data source that's going to change. We've got our client logic that is unique to our environment. We've got our business entity or domain objects that we're going to move between our client logic and that data source. In the middle is the repository. The work that's going to differ, that the Spring Data portion is really, that we're going to play around with, is in the data mapper. There's a whole lot of secret sauce, though, in the middle there. So I like concrete things. So let's go and take a look at one of the base interfaces. What you'll see here for one of the out-of-the-box repositories, the CRUD repository, is we've got all our basic functions. We've got to save, find, whether it exists. It doesn't matter what type of database we're going to use. I got to believe you're going to use those functions. These are the core for any sort of data access. What Spring Data adds to it, in addition to having a very easy interface for this, which we'll talk a little bit more about in a moment, is some of the goodness that came out of the Grails and Gorm community. So we can go and set up a bunch of finders. So if I want to go and implement to Oracle via JPA using Spring Data, because I think that's a good solution at the moment, I can go and specify a finder of find by last name and first name. And that is going to be automatically created by the implementation for the database repository. This is about all the code I need to put in these finders. That's pretty cool to me because it means I have less code. I learned a while ago that there's a reason why defects a long time ago were measured in terms of defects per 1,000 lines of code. It was explained to me differently than I now know it. It's because the more lines of code you write, the higher the probability is you're going to screw something up, or at least the higher probability I will screw something up. And so anything that will reduce the number of lines of code that I put to electrons, that's a really good thing. So let's go and look a little deeper into our interfaces. So here we've got one of the Spring Data interfaces going for GemFire. The GemFire repository is our interface out of the box that's provided. We're extending it for our contact domain object. Our naming convention is the domain name repository for the interface. And then the real secret sauce is down here at the end. And what we're specifying by saying we're going to use the GemFire repository, we're saying that we're going to use the domain object contact and that we are going to use the primary ID of long. With this, all I have to do is just change that little bit for whatever database I want and a few other things that we'll see about soon. And I've now changed from my Oracle JPA-based database that's kind of clunking along to a much faster, lightweight, agile thing like GemFire. Now you'll notice down here, I've specified my finders. So I can extend that interface to go beyond the CRUD repository methods we saw a moment ago to include whatever finders I'd like. GemFire would look like this. Guess what? If I went over back to Oracle, it would still look like that. I do need to make a couple of other changes, and I'm going to need to do it at the domain level. Let's take a look at our architecture again from the perspective of the domain object. So here we have our domain object, and I'm going to need to make two changes. Because I'm going from a JPA to a GemFire example, I'm going to replace the @entity JPA annotation to an @region for GemFire. That enables me to take advantage of the special features in GemFire. I'm also going to change that @ID for a more generic type ID lookup that is more compatible with a broad spectrum of databases. That's all I had to change. Not a single line of Java code got changed there. So if I'm going to argue to accept this in my enterprise, I've just gone and reduced the risk. So I can say you do not have to worry about your logic changing in converting your legacy application over to Spring Data, because all I'm doing is I'm changing those annotations. And I'm setting it up within the Spring Data context. And because we're going into the Spring world, what it also means is we're going to have a more testable application. Now, let's look at all of this stuff together. The top part here is our XML configuration. You can use an @ annotation. And all we're specifying is that we're going to use the GemFire repository. The interface we saw, and one of the things you'll notice in this slide is I've changed the return data types. I have some control there. That's very cool. But what's really cool is this block of code right here. Let's take a look at it. Well, I have a create customer, and all I'm doing is I'm calling customer repository, which we'll get back to in a moment, .save, and then the customer domain object. Delete customer. There's my finder. All I have is that repository interface reference. I change from GemFire to Mongo. All I have to change is that. That makes it a whole lot easier to go and work with. And it also makes it testable, which is very important. On queries, I can go and support all of the native queries of all of the supported databases. So I'm not trying to homogenize it to one common set of functions. I'm giving you the ability to choose the type of queries that you want by putting in this @query annotation. Here I have the select statement from GemFire. It could be a traditional SQL 92. It could be a MongoDB. It could be whatever I want. The find by attributes will remain constant no matter where I change it to. This is very cool. And of course, with the object reference, just another interface, class. I also have a full set of tools. For those of you like me who can't remember anything beyond a couple of seconds, I can do Control Space, and it will tell me, so long as I've got my interface set up right, it will tell me how to set up my finders. Now, this is, I think it's really very interesting, very promising stuff. And as I said, I was very skeptical when Spring Data first came out. And I have to say, I'm still skeptical. I'm not certain that it's as easy as we're saying. I believe in being honest. So, Dave, I'm going to make a bet.
Uh-oh.
So, what I want you to do, because you've been telling me all this great stuff that you've done. You've told me that you can easily move from something like a JPA implementation to a GemFire.
Like that, yep.
I think that's a bold claim, my friend, very bold. And I don't think you can do it in the remaining time that we have.
Okay.
I bet you $1 that you can't.
Okay, you're on. I just want $1.
All right. Who do you think is going to win the dollar here? All right. So, David, prove it to us.
Okay, so looked at some slides. Let's look at a demo. So I have a contact management application, and it requires a simple domain model with 4 entities. You have your primary contact, first name, last name, has a billing and shipping address, and the contact can have many phones and many emails. So that's the domain model. I'm going to use similar architecture as Mark described. Essentially, it's a web application using Spring MVC. We spun it up with Rue and did it for the scaffolding and did a very few modifications on it. And right now, it's running with the JPA repositories backed by MySQL data store. And so I've got JPA annotations on the domain model. So let's take a look. Oh, and so what Mark has challenged me to do is to swap out MySQL with GemFire data store. And we should be able to do that. And I'm going to assert we can do that without changing our domain models, without changing our controller or view.
Now, Dave, I want to be clear. I don't want this to be a hello world example, one domain object. I want this to be real.
Okay. Well, we've got 10,000 rows in the contact database right now.
Wow, that's a lot.
All right. So I've got 3 VMs running on this laptop. So I have a MySQL server, and I have 2 VMs that are dedicated to GemFire. So I'll have two GemFire servers so we can distribute the data. And really, all I have to do is swap out the repository definition, and we'll get into that. I need to change my connection information. Obviously, I'm connecting to GemFire, so there's going to be some infrastructure level configuration that we can easily accomplish with Spring. And I'm going to change the annotations on the domain model, but that's about it. So
you're not going to change any Java code to make this happen?
Yeah, there's some XML change within the Java. I'd say probably less than 20 lines of code that I have to change.
20 lines of code or 20 lines of annotations?
Yeah, mostly annotations, yeah. Well, we'll see. We'll take a look, see what I have to change. So flip over to SpringSource Tool Suite. So we have our web module, and the repository is in the contacts JPA module. So let's take a look at the domain object first. So this should look familiar if you've done anything with Hibernate or JPA. We have an entity. Contact is annotated with that entity, a standard JPA annotation. And that tells it we're going to persist this. The entity manager knows to persist this domain object. We identify the primary key as the ID field. We have some versioning. The not null is actually not part of JPA. It's actually part of the Java validation framework, but that's supported by Hibernate. And we can actually use that with the GemFire version too. And so here we have some associations, right? So we have one-to-one. We have a billing address as a one-to-one relationship. So we have an address table, and each contact has a billing address and a shipping address, 2 entries in that table. And we have one-to-many for our phones, and we have one-to-many for email addresses. So that's pretty much it. If we look at, say, address, same thing. We have entity annotation. So as you would imagine, our data is normalized. We have a normalized SQL model. It's interesting, though. For this example, the data really doesn't have to be normalized because email address isn't really, it's dependent on contact. They're not independent entities. We don't need to find email addresses unless they're associated with a contact. So we're doing a lot of joins and things behind the scenes, and we really don't need that. That's an artifact of object relational mapping. And with NoSQL or GemFire, you actually can do away with that, and we'll see this in a minute.
That'd make this a lot faster, wouldn't it?
Well, GemFire will make it faster in general, but it'll make it a lot simpler to maintain, that's for sure. So let's look at the repository interface. So this is in the web module, I'm sorry, the controller. Look at, no, sorry, the repository interface. I want to go there next. So we have a contact repository, and this extends JPA repository, so that gives you CRUD operations out of the box. JPA repository extends CRUD repository. And we have our query methods. So Spring Data Infrastructure is going to go and find this interface declaration. I don't have to write any code to do this. That's it. There's no implementation other than what Spring Data is going to generate for me behind the scenes. And behind the scenes, since it's JPA, it's using an entity manager, and it's configured properly. So these methods, query methods, are derived from their name, the method name, and the repository knows about the domain object, and so Spring Data does a good job of introspecting that domain model and finding all the fields and all the type information and everything it needs to be able to actually generate these queries on the fly, and ends up generating a proxy implementation of this interface. So I don't have to do the code. But since it's Java, I do have to tell it which methods, which query methods I'm interested in proxying. I can't just do it dynamically like you can in Groovy. So that's it. I mean, I have my domain model, my repository. Now I have some Spring config I want to look at. So in the application context, I have a repositories element, and any of you saw, how many of you were at Oliver's talk yesterday when he went over the repository deep dive? Anybody there? So he did it all without XML. So I'll show you how to do it with XML. I'm old school. I like XML. But essentially, this is equivalent to the Java config at enable JPA repositories. You basically, in one element, you tell Spring which base package to scan for repository interfaces, and it will generate those. And that's it. So the other configuration that's necessary in this case is all your standard JPA entity manager stuff. I do want to point out something here. So I have my JPA vendor adapter. I have my data source connection information. And as I said, the deployed model is going to go remotely using MySQL to a MySQL server that's bound to this IP address. Now, I'm using Spring profiles, environment profiles. This is my default profile, which will require a remote connection. But if I want to unit test, I can use an in-memory database. So since it's JPA, my unit test doesn't care where, what kind of database it is. It's standard. So
I'll be able to make it easier to go and test my database, make certain the migration is successful, and make certain I don't get called up at midnight on the day after deployment. Is that what you're telling me?
That's what I'm telling you, yes. So,
Uh-oh.
So that's what's in that repository implementation pretty much. If we look at the controller now, we can see that it's wired in this interface, contact repository. So best practice, interface dependency injection. We're going to use this repository, and if I do a search for this, I can see that it's being used to back this controller. Now, I want to focus on this method, which we call list, because that's what I'm going to demo. So quick and dirty, it basically, by default, if there's no query parameters, it'll do a find all, but we have paging support in Spring Data. So I pass it something called a page request, and it will go retrieve the next page of data, and I can play with the page size and so forth. So we'll see that. If I pass it a first name, I'll call find by first name, and we'll do it. So we'll do a search on first name. And if I pass it a last name or a prefix for a last name, it'll do the find by last name starts with. So let's take a look at this app. And here it is running. So just make sure. Like I said, we have 10,000 entries in here. So I'll set the page size to 5 so we can see the paging a little better. And we have 2,000 pages, so 10,000 entries, and we can flip through them. Again, we didn't write any code to do this. We just set up our paging parameters. And if I want to do...
So while you started this out in Rue, this has a lot less code than the generated Rue application, doesn't it?
It does, yeah. I threw away a lot of the Rue stuff. But Rue helped me get there, because I don't remember how to do an MVC app in time for a demo like this. But it actually worked out pretty well. So here we have Mark Johnson. We found him. And if we want to look at by first name, see if we can find, we get all the marks. And somewhere in there we'll find him. There he is. Okay. So very good. So guess what?
This is impressive, but the task is to move over from one to the other.
Well, this is what happened. I mean, I showed this to our boss, our CEO, and he was like really impressed with this contacts app and wants to spin off a venture to host this as a software as a service and sell his contact service to Google, LinkedIn, and Facebook. So we're going to have to scale this thing out.
So he's going to get rich, and we're working all night doing a traditional migration.
But our MySQL, yeah, I mean, it's
I got
always
plans
like that.
tonight.
I don't know if it's a great business model, but our MySQL database isn't going to cut it. We're going to need millions of contacts. There's 6 billion people in the world, and they all know each other. So it's going to be, we're going to need a lot of scale for this, and we want to have consistent response time when people are using this and getting this stuff over their mobile devices. So we're going to have to cut it over to GemFire. So let's go back here. And I don't know why this console window keeps popping up. That's annoying.
Now, I'm serious. I want to go to some other sessions, and I think these people do too.
So you think there's going to be a lot of work to do?
I think I'm going to have your buck.
All right. Well, last chance if anybody wants in on this action, but here we go. So I will say I cheated a little bit. I'm a pretty bad typist, and so I pre-prepared some things. So
I'll let you go on that one.
I'm not going to change the stuff in line. I have another implementation, Contacts GemFire, but we'll look in and you can kind of get a feel for what we had to do here. My web app isn't going to change. I'm going to use the same controller interface, same controller, same interface, same views. But I have this Contacts GemFire. So what's in there? Well, it looks pretty similar. I have, let me shut this down a bit. So my contact, it's the same domain model, but I need to change the annotation. So now instead of @entity, we have @region, like Mark showed you before. We have an ID. We retained our JavaX validation for grins. But what happened to all the associations? Well, we don't need them, so I took them out. So there's some work to delete those annotations. But it's essentially the same value object.
But you didn't need to do that, did you?
I could have left them in, actually.
And it just would have been slower, and we would have been working later tonight.
Well, a word about @region. This associates by default to a region of the same name as the class. GemFire region with the same name, contact with a capital C. If I wanted to use something different, I can provide that in the annotation as an attribute on the annotation, what the region name is. But we'll keep it simple. I still need to tell GemFire what the key value is because we're essentially a keyed object store. And so Spring Data needs to know what to use for the key. This ID annotation is not the JPA ID annotation. It's a version of that we provide with Spring Data, but essentially accomplishes the same thing. And then there's no associations here because guess what? They're already in the object model. Java knows how to handle these associations fine. The fact that you have to do that is an artifact or a consequence of having to normalize your data because SQL can't handle collections like this out of the box. So you have to keep those in a separate table. I don't have to do that now. I'm going to just stuff this whole object graph into one entry in my region. So that was one change. I think it's simplified because, like I said, these dependent objects we don't really care about. I don't need the overhead of keeping them in separate regions. And then you'll see I had to remove the annotations from all the other classes. They have no annotations, just value objects. Now my contact repository, the interface hasn't changed, but I now am extending GemFire repository instead of JPA repository. It still gives me the basic CRUD operations, and the query methods are exactly the same. So as far as the controller is concerned, it's the same interface. It doesn't care. I had to do some work though, Mark, I will say. This was the hard part. So GemFire, Spring Data GemFire out of the box does not support paging and sorting. It's very difficult in general because GemFire natively doesn't have that kind of capability. Maybe in SQL Fire, but not in straight GemFire.
It is in SQL Fire.
Yeah. So there's no way to do it, to do a cursor on a plain region. So, but I figured, well, I can do an implementation because in this case, my keys are longs. So I can do an OQL query and just select a range of keys and do my own custom paging implementation. And so the way I did that is I wrote an implementation of something I'm calling custom paging repository, which gives me the same method that I need to do this find all paging. So this interface is the same as what is provided by JPA. Now to do the implementation, I'll admit there was a lot of work here, Mark. I mean, I don't know, but I have to pass an OQL query, and for this I'm actually using GemFire template, which is a.
But that's all you're doing, just that handful of lines?
Well, I'll show. It doesn't all fit on the screen right now, but you can see the OQL query basically getting from the page that's passed in what my range is, and I'm just translating that into an OQL query, which will select from contact region where the ID is greater than or equal first and less than or equal to last. So that was, I thought was pretty clever, and I pass it the parameters I need. This GemFire template is part of Spring Data GemFire using the template pattern. If you're familiar with JDBC template, Mongo has a template. So basically a convenience class or a helper class to access data from GemFire. And then for grins, I decided to sort the results by ID. The page size isn't very big, so it doesn't really cost a lot.
It doesn't look like it was that much work.
No, it wasn't that much work. So that's it. So I'm going to swap this out in the web application. So
wait a second, you're saying that's all you did to migrate?
Did we look at the, well, let's look at some configuration here. We have something very similar on the Spring side. Again, we have our repositories element, but this time instead of a JPA namespace, we have a GemFire data namespace, which is backed by different beans. So when Spring Data uses this, it's going to use a base implementation that uses GemFire regions. It really uses actually the template internally rather than the entity manager to do all the data access. So it's going to generate all the code for me, and so that's pretty much the same. I had to swap the namespace, and then I had to do some GemFire configuration. I just want to look at this a bit.
But you would have done the same sort of stuff for a traditional database, really.
Yeah. So GemFire has a client-server topology that we're using here, and uses something called a locator, which you might be familiar with. So basically, locator is one process that lives on a server somewhere, and it supports discovery of new cache members as they come and go, and also does load balancing and things like that. So the locator is very nice. The client only needs to know how to contact the locator. It doesn't care where all the servers are running, how many there are. As a matter of fact, there's nothing that really tells us much about how this region is implemented here. It's just saying I have a client region and a client cache, which is basically just a proxy, client-side proxy, to get at the data that's going to be on a remote server. So what I need to do at this point, I have 3 terminal sessions set up. I couldn't get my tmux to work yet. I really liked that from Adrian's speech last night, but I have 3 telnet sessions that are going to remote servers. Or they were.
Remember, Dave, you got to load all 10,000 rows to win the bet.
This is my MySQL server, and we can see we have 10,000 rows in the contact database. Uh-oh. Famous last words. Okay, so I don't know what happened. My VM quit on me. We have a little network glitch here. 134 now.
Yes, the challenge of a distributed data store is you are dependent upon holding a network connection. And when you're connecting into a conference line, holding that network connection can be more than a little challenging.
Right.
I'll give you a break, Dave, in terms of the bet.
You're going to give me a break here?
But okay. Just on this part.
How are we doing on time?
I think we've got a half hour.
That was one we just saw, okay. It's 135, so let's see. I'm going to start up the locator. So this is going to take some work, since this is the brittle part of the application, is that all the IPs are hard-coded in the config. So let's see what we can do here. We'll start up a cache server.
And while you're doing that, just some commentary in terms of distributed systems. So, when as we see here, one of the challenges when you're looking at multiple box coming together is making certain that they're all talking and that they can all find one another. When you're looking at a distributed grid, you go from one box that's very clear to know where it's located to, in some configurations you can be looking at 100, 200 boxes easily that are holding the data stitched together. Now, the advantage we get is with those, say, 200 boxes, we now have 200 NICs, 200 memory controllers, 200 I/O controllers, and so we don't have to worry about, getting that 200 zillion gigahertz I/O throughput. We're just going to stitch together all of those controllers, and we get much better throughput performance because we've got all that additional capacity. The individual request response time won't change, but the total throughput will by adding more components. Now the downside, as many people point out here, is that, well, I've got a lot of servers I've got to manage. One solution that you can take is using tools as David is using Gradle to go and help you go and add more components. You set up a set of scripts within your environment to go and add the additional components. So if I need to elastically, going back to the PowerPoint example I showed a while ago, elastically add 2 additional server nodes, all I have to do is execute a Gradle, add 1 and run that twice, and it will take care of identifying all of the mapping so that it'll work. David's approach was he hard-coded it, but that's generally not a good practice. In fact, it's a pretty bad practice. You want it to be dynamic. One other tool you can use to help in that dynamic is a tool called Application Director, where you can build a blueprint for all of these servers and have it grab the IP addresses so that when you go and deploy to a new environment, you're not going to experience what David is going through right now. It is very uncomfortable to run into this situation, especially when you're doing it in front of your boss. A little less uncomfortable when you're doing it in front of a large audience. So Application Director and tools of its ilk that are able to grab some of the configuration settings gives you a real resiliency in the environment, so you can quickly set up things and you don't have to worry about making typos and whatnot. So that's a very important consideration that you want to have when making the movement to more of a horizontal scale or a diagonal scale. Diagonal scale being where you decide you need a little bit more horsepower per process, but you still want to go out horizontally and you get more expensive servers and you just have more of them. How are we doing there?
You say, I think there's a problem with the locator.
And meanwhile, could you
Yep.
explain the difference between GemFire and SQLFire?
Yes, I'd be glad to. So they both use the exact same engine that gives you the durability characteristics that I described, the scalability, and all of the other features that you find in what we traditionally refer to as GemFire. The difference is the interface. So like with Spring Data, we're using an interface to allow change. Here we're allowing an interface to allow us to keep very reliable technology, that being GemFire, to go either object-oriented, as we've been demonstrating today with the traditional GemFire API, or we can go SQLFire that gives you a full SQL 92 interface to that same data set, or that same engine of data. With it, you can migrate applications that do not get overly heavy with joins very, very quickly. All you need to do is point a new JDBC driver, set up the node configuration, as David's doing for the pure GemFire approach, and a few SQL DDL changes to specify whether it's going to be a partitioned data set or a replicated, then you're off to the races. I've seen SQL applications get migrated, and real ones, real world ones, in half day.
Okay, I'm back. So I'm loading my cache server.
Hang on. Does that answer the question in terms of the difference between SQLFire and GemFire? Okay.
Okay, I just loaded my cache server, so I'll just use 1 instead of 2 for sake of convenience here. So we have a single cache server running, and I just loaded all 10,000 objects into it. So now I have to make a change to my web app, but only on the build. So in here in the properties, I have a Maven profile that tells me to link in which repository to link. So I can change from JPA to GemFire, and now I'm going to link with the contacts GemFire repository and the dependent GemFire jars.
Since that isn't too many lines of code, I'll let you get away with that bit of cheating there, Dave.
Yeah, a little bit of cheating. So So we built that, and so now I'm going to restart the app. And it should work fine. I'm ready to collect my money.
Hey, I still don't see those rows in there. I still don't see that,
Even with
that
the demo
functionality.
guide.
I don't believe it. You know, this is Hello World. You know, prove it.
All right, so we left it. We were using a JPA repository, which I've output here. So now we're using a GemFire repository, and we've got the data. Let's see if my paging is...
So this is all going across the GemFire repository. It doesn't look like you changed anything to me.
Yeah.
It looks like it's the exact same application that our boss liked before.
My paging still works. Yeah, we might be out of the woods here. Let's see. Finder method. You think they'll work? I don't know.
No, because things never go that easy.
There you go. Mark Johnson. All right.
Oh, shoot.
Oh, just for that.
Thanks.
You're out.
Deleting me.
All right. Doubting Thomas. All right. Let's do the first name query. And
Certain this isn't some sort of JPEG that you're kind of flipping between there?
no, this is...
You just went through all sorts of problems there, man. And that's a fully functional application for a contact manager.
That's it. And so we're ready for web
And let's
scale.
just double check. Is there 10,000 rows there? Yeah, go down to the bottom there.
Maybe there's one less now. But same number of pages.
Oh, boy. Do you guys think he won the bet?
There we go. Yes, even with the demo gods cursing me. Thank you. So,
Guys, that's really impressive when you think about it. You know, real world is there are going to be problems. It always happens. It doesn't matter what your tool is. And admittedly, we did script this, more or less. And everything worked fine when we were doing it up front. What happens when we go and sit in front of you guys? Just as the same thing that happens when you sit in front of your boss. Something goes wrong. The number of changes he made, he could have typed in this duration. We just didn't want to have any typos or whatever to distract. That's impressive. And I did, quite a while ago, say to a friend of mine in the back of the room that I didn't think Spring Data was going to go anywhere. But, I'm convinced, because in the 1.2 release with the repository, what we've done is we've set up a common interface that really enables you to very economically access any type of data store. But we're still able to use the magic and wonder of GemFire or of the JPA if you're so inclined to deal with more of a vertical scale. So getting to the decision of right way, wrong way, I don't have to choose. Well, I do have to choose, but I can make a mistake. We all make mistakes. And there's less lock-in, but even if I know I want to go JPA, what he demonstrated is a whole lot less code than you'd see in your traditional JPA implementation. That's impressive to me. That's really impressive.
well, if I can impress you, I could impress anybody. But yeah, so we did it.
Now,
This, I just wanted to point out, for more information, we have the home page for the Spring Data project, the URL there. We've got forums.
well, before you get to the wrap-up, I want to earn something for that dollar. So we were talking about testing, and testing is one of those topics that is often talked about. People in front of podiums and conferences say you should always do it. Did you test here?
Well, let's see. We did the functional test first. I did not do the unit
Okay,
test.
so functional test works for me. Prove it.
Well, let's see.
Because that's really the key, because if I'm going to go and do a migration at work, what's going to happen is they're going to say, well, we need to spend 6 months testing all of the code. But if I have a good testing approach, a good testing framework in place, maybe I can trim that to a more reasonable couple of weeks.
Well, we do have some unit tests included here. Not great test coverage, but I needed to test.
It looks to me like you wrote more lines of code for your unit tests than you did for your migration.
I always do. I'm a big believer in test-driven development. I had to test out my custom paging implementation, and wanted to make sure that the basic repository was set up correctly. So this is more like a JUnit integration test. Again, I auto-wire the contact repository. I'm using a GemFire template to do some initial loading, which I could have also used the repository for. But as you recall, the configuration this time, since I'm in unit test mode, is actually using, I don't need a locator. I can set up using Spring configuration namespace for GemFire, a local region, and an embedded cache, and I can run this test against that.
So what you're really pointing out there is I can really test a fully distributed federated database using JUnit tools and all of the Spring goodness that I've been using all along. That's what you're saying to me, right?
Yeah.
Actually, I think you're doing more. You're proving it to me.
I'm proving it. I'm going to run.
You don't want to give back that $1, do you?
Got to have that green bar. Yeah. And it's the same thing with JPA. Same kind of deal where I can test with an in-memory database. Same thing, we're using the same contact repository. As a matter of fact, in the real world, you should have a common test suite, and you would do this in line, your repository implementation in line, instead of setting it up so you swap out different jar files. My tests were located with the repository, but I could have had a separate module for running the same test suite against the new repository would have been better. But I had some similar things just to make sure that you're basically configured correctly and running. So this test runs against in-memory hypersonic SQL database. And can try that too. Yeah, one of the reasons I jumped to that last information slide, though, is because if you're interested...
Now, this was the JPA example you just ran.
That was the JPA example I just ran. If you're interested in looking at this code in more detail, I know we went through it pretty fast. It's all out on GitHub on my repository. And I don't know, I lost my lease. All right, so... That's which screwed up my my DNS for my VMs, but it's on the slide. So look under D. Turanski on GitHub, SpringOne 2012, and the code is all there, and some instructions in the README as to how to set it up if you want to try this demo yourself or play with it.
All right, so that means we actually we get to go home early because this stuff actually works. Because we now converted your application. You can go off to that Google reselling that you were talking about, and we're done for the day.
Does anybody have any questions? Yes.
You guys didn't mention anything about replication, and I assume it's eventually consistent system by solution, right?
The question was about replication and eventually consistent system. Well, so I actually had this demo set up for partition data. So if we had to scale out lots and lots of data, there's a limit to how much you can get on each server. So you want to spread it out. Partitioning is also optimized for data that would be written a lot, updated a lot, because it's a single hop. You don't have to replicate across all your nodes. Now with GemFire, with replicated region, which is the other choice, you have a choice to make there too. And you'll find if you look at GemFire that there's a lot of knobs and dials you can play with. So with a replicated region, you can tune that and you can say replicate asynchronously or replicate synchronously. So asynchronously. It will update a primary member that's hosting that region, and we'll throw this event on a queue, which will get picked up, in a separate asynchronously, so that you'll have eventual consistency. But if you really want it to have synchronous replication, then you can configure GemFire to do it synchronously and actually not complete that transaction until you get an acknowledgement back from all the replicas. So that's obviously a lot more expensive, but GemFire's philosophy is there's a lot of use cases, and it's really up to the needs of your application, what you need to do. I know in the SQLFire talk, Jags mentioned that SQLFire is always synchronous replication if you have a replicated region. So that makes sense for something that would be, you have ACID semantics.
Can you share the algorithm you use for the synchronous replication?
I can't. I'm not part of the core GemFire development team, so I just expect the stuff to work. Spring GemFire is really about making GemFire easier to use for application developers and making the configuration easier, simplifying doing what Spring always does best, which is separating out the infrastructure concerns, configuration concerns, and let you focus on your business application logic. And so we're providing first-class support for GemFire there. But the actual replication algorithm, there are some folks here from GemFire that could answer that question for you.
All right. Any other questions? Yes?
So what's the difference between Spring Data GemFire and vFabric GemFire?
The question was, what's the difference between the Spring Data GemFire links and the vFabric GemFire? Spring Data GemFire is an open source Spring project that's under the Spring Data umbrella. GemFire is a licensed commercial product that's owned by VMware. And so the vFabric GemFire is the official product name, and this link is to the home page, so you can download and then install GemFire, get more product data sheets and more information about it. And Spring Data GemFire is open source, and so we host the project homepage on SpringSource, and we have the code freely available on GitHub.
Any other questions?
Can you elaborate a little more on the process of migrating the data from your MySQL database into the database?
The question was to elaborate on the process of migrating the data. Well, that's a very good question, and
why don't I take a stab at that one? So for migrating the data, there's a couple of ways you can take. If you're going to a traditional SQL database to something like GemFire, one approach that's available to you is you can use the cache reader, row loader type interfaces to just go and pull the data from that legacy store into your data store, your distributed data store. And with that approach, you're setting up a forward cache pattern, database forward cache. You still have that legacy underneath, as I described when I was talking about durability. But it'll just bring everything up, and you really don't have to spend a lot of time other than in that connection point doing the migration work. Another approach you can take, which is what David used in the demo, is you can just use an import or a loader utility and just dump the data into, say, for example, a CSV file and then import it. One of the other things, though, you really need to think about that's sort of an offshoot of your question is not loading the data between the frameworks. That's just the traditional sort of move it from one bucket to the other. The question is, do I really want to just move the data unadjusted from one data store to another? And the answer, I would argue, is no. You want to think about the data modeling. And in fact, while what David showed is technically, from a programmatic perspective, very easy, and dealing with like a SQL file, you can make it just drop-in compatible, you do want to spend some time thinking about how that new tool is going to work best with different organizations. And so you may want to consider co-location strategies and a bunch of other federated data patterns and strategies for changing your schema. Now, if you decide that you want to change the schema from your traditional relational to something that works with your new data store, now your data transfer process got a little bit more complex because you're probably going to have to do some transformation of the data to merge rows, to create a fat object if you're going with a GemFire or one of the hierarchical stores, to think about a common co-located key to keep the data distributed across all of those nodes. And that would be the effort, is just figuring out that mapping process.
Yeah, I agree. I think I've oversimplified the mapping problem a little bit because things like that you have to think about. So you've got normalized data. Do you need to have it normalized? Or is that a hindrance or an impedance, or is it really helping you? There might be reasons why you actually would want to store these things in different regions, and then you would have to do a little bit more work to do that, to do that engineering. I brought up the code here. I mean, basically, I ran the data loader, and I'm using a repository to read from the JPA, from the MySQL database. I just do a find all and load them all into memory, and then use the region itself to migrate the data. I had to do a little bit of messing around with because I was getting Hibernate proxies for those collections, and I needed to basically create a new hash set from those to get rid of that Hibernate type, which GemFire was complaining about. Didn't know how to serialize it. And I could, and if you're going to do something like this, you could also use repository on the receiving end too. But because of the way I implemented this application, contact repository was the same type in the same package with the same name. So I can't have both those jar files in the same application. If I called it, org.example.gemfire.repository and actually change that interface type, then I could use both in the same application. So it was a trade-off. I decided to keep the migration demo simple and do a little bit more work here. Did that answer your question?
All right. Any other questions?
Jane?
Yes, James.
Load.
Yeah. You want to...
You're asking about doing extract and load processing? Yeah, so, well, if it were me...
Repeat the question.
Yeah, it's a good question. So the question was, are there any good frameworks that we would use or methods we would use to do, a more complex kind of migration process that would require extracting items from a source system, doing some type of transformation to the data, outputting to the target system. And I think it's kind of a loaded question. We'll give you your $20 later. But yeah, if it were me, I would definitely use Spring Batch and Spring Integration to put that together. It would be very easy to do all of that with those technologies made for that.
Yeah, I'd give that answer even without the $20 that you took. All right.
Any other questions?
All right.
Well, great.
Well, thank you, everyone. We enjoyed presenting to you.